Hello and welcome to this teaser video. My name is Anton Janssen, and in this video I would like to talk about the work I did during my bachelor thesis with the title Engineering a DSL for Logging Statements and its Application in Generative Software Engineering. First, I would like to talk about the practice of logging itself. Generally, logging refers to the practice of creating and collecting runtime protocols during the execution of software systems and software applications. This usually involves the placing of logging statements manually by the developer in handwritten code. There are several issues surrounding contemporary logging practices that I would like to mention first. The first one is that logging is usually done at a very individualistic level. This means that the developer writing code places logging statements based on random factors and variables that might be unknown to potential other developers that are working on the project, which directly results in the second issue, which is the lack of consistency when it comes to the placement of logging statements. The third and final issue is that there is a very definite lack of high-level tools for developers, which makes it tiresome and difficult to interact with log printing code in software development. Some of these issues are also present when we look at the source code generator MontyGem. MontyGem is a generator that employs models of different domain-specific languages for configuration and setup, and then generates an enterprise information system based on model information. It also uses a template structure that contains several different templates for generation purposes, and those templates contain logging statements. The integration of a domain-specific language for logging purposes can provide several advantages when we look at MontyGem. Models of a logging DSL can be designed to be very intuitive to read and write, and this allows for quick changes to the logging behavior in the generated enterprise information system. This is done by using the models as initial generator configuration. The role of logging models is illustrated on the right-hand side. As we can see, several different models from different languages are used for generator input. The generator itself also has a template structure consisting of several different templates that are used to generate the source code of the information system. The information system itself has several different components, with one of them being a log file. And the contents of this log file are ultimately decided by the logging model here. So not only can we avoid the generation of redundant logging statements in the information system, we can also shrink the log file size. The overall goal here is that models of the logging DSL can be utilized to control the entire logging behavior in the generated system. This means that ideally, developers no longer have to directly interact with the logging statements in the templates of the generator, but can instead configure the logging model to suit their needs. I would now like to talk about the implementation that was done as part of the thesis. The implementation can be split into two projects. The first project contained the DSL, the actual language, and all its supporting language infrastructure. The second project, on the other hand, contained the modified MontyGem generator that was changed to respect model information from the logging DSL. The first project contained the grammar of the language, from which models of the language are derived, and also the language infrastructure generated with Montico. The ultimate purpose of this project, however, was to build a language library that would then be used in the second MontyGem generator to process models of the logging DSL. The second project contained the modified MontyGem generator. This generator was extended to first retrieve logging models and then process them in a separate utility in order to decide whether a logging statement in a specific template should be generated or not generated. I would now like to show how this process looks like in practice. On the left-hand side, we can see a model of the logging DSL, and on the right-hand side, a template that was modified to respect model information when deciding whether to generate a logging statement or not. Specifically, we're interested whether a log configuration exists that matches with the logging statement found in the template here. In order to check this, we call logging utility, which is responsible for processing models of the logging DSL. The logging utility then runs through the model and checks whether a valid log configuration exists. In this case, this is indeed true because log configuration 8 matches with the parameters given in the method call here, and this whole expression would evaluate to true. This means that the line in line 10 would also evaluate to true, and the logging statement would then be generated.